Hello, everybody. Welcome to the Construction Show. We are filming in studio here, and I'm excited to have for our Part 5 episode with Graymont to talk all about Graybond is Lucas McFarland. He is a new product application specialist with Graymont. Lucas, welcome to the show. It's great to have you on. How was your trip in?
Yeah, thanks for having me. It was good. It's a quick flight from Salt Lake City up here to Vancouver. So
yeah, I hope to get down there soon. Actually, maybe for SME next year. I guess just to jump right into this, we're going to be talking about Graybond in depth for what it's used in concrete. To start off, why would a company want to replace a portion of cement in their concrete paving project?
Sure. That's I think the big question that many of these alternative cementitious material businesses are trying to answer for themselves, and it's the most important one. And I think all of us who are in this sort of industry, the major driver in wanting to replace a portion of cement is a carbon reduction, right? So cement, or I guess concrete, I should say, is the third most material consumed globally after energy and second only to water. In that, cement, it makes up a small portion, usually like 10 to 14% of the concrete matrix, but cement production is actually responsible for somewhere around 8% of global CO2 emissions. So even making a small reduction or a small swap out of some of that cement in the end concrete matrix can pay off huge dividends in carbon savings.
Right. So just because it's so intensive compared to other products.
That's right.
Okay. Graybond is sort of a binder, right? It's being used as a replacement.
That's right.
So, and that part of it is where a lot of the emissions come from, and that's where you're trying to improve on that with Graybond. And we're going to actually get into it because I think you're getting into testing, right? In like a recent trial with Graybond as well.
Yep. So we have a fully operating facility now. Graybond is in production at our plant in Superior, Wisconsin.
Okay.
Right on the water there. It's 150,000 tons per year facility. New of its kind for Graymont. It's a brownfield plant, so we were able to refurbish some of our material to build what we would still call a state-of-the-art facility, even though it is a brownfield plant. But yeah, it's being used, and we had our first ever concrete paving trial actually at our Indian Creek facility in Montana just almost a year ago now, September of 2024. So
okay, so maybe that's a good place to get into. So what was the goal for this trial that you did there at Indian Creek?
Right. I think this trial was really proof of concept, getting into that high technology readiness level for Graybond that most products go through, right? So there's sort of like 9 steps in a technology readiness level scale, and we were trying to get from, I think, level 7 to level 8 or something like that. So we had proved Graybond out at the lab scale, and this pilot trial was to prove it out at the pilot scale at a real life plant and real life operation. We were looking to replace 25% of a cement mix, and we're looking to test the durability over time. And I think that's probably the most important part of this trial, is we're going to be able to look at these pads that we poured at our Indian Creek plant after a year, after 10 years, hopefully after 20 years, right?
Mm-hmm.
Hopefully we will be looking at this after 20 years. So
is that the goal, is to like have this be set up and not have to be replaced then for a much longer period of time?
Yep, that's the goal. So put it up against the regular concrete that only used the Type 1L cement as its binder. A Type 1L cement is a limestone cement. So it's usually like 5 to 15% limestone fines mixed in with the cement binder. That's the general use cement that's used pretty broadly across North America now. So our Indian Creek paving project, it was a massive, it was really quite a massive paving project. I don't know exactly how much it covered, 3 football fields at least. And we did 2 Graybond sections that were, I think it was 14 square yards in total.
Perfect.
So the whole goal of the Graybond, or the whole goal of what we were trying to see in the lab was, well, which Graybond performs the best and meets standards. So in B2, we used a calcium hydroxide blend with a little bit higher pozzolan and a little bit less of the calcium hydroxide. And in blend B4, we used a quicklime calcium oxide blend that was a little bit higher in overall calcium oxide and a little bit less in pozzolan. But our lab research actually showed that higher calcium oxide blend to be the better performer, but it would be a little bit more exothermic, and there was maybe some more challenges down the line having more of that calcium oxide in that mix. So we picked these two blends, the whole goal trying to be, well, which ratio is the best for the amount of pozzolan to the amount of reactive calcium, right?
Let's talk about our heavy industry world tour brought to you by Savona Equipment. Find, market, and sell surplus and used equipment. And Corporate Traveler Canada, helping companies travel the globe simpler, faster, easier. We are heading to events across North America and Australia and filming episodes on location. Email us at info@crownsman.com to be part of Crownsman's Heavy Industry World Tour. As heavy machinery specialists for construction, SMS Equipment knows performance, like the performance they achieve together in a partnership dedicated to the success of their construction customers. At SMS Equipment, they're more than machines from trusted brands. They're the people beside you today and every day, bringing industry-leading technology and expertise to your job site. Because the right partnership makes everything possible. SMS Equipment, partners in your possibilities. Discover what's possible at smsequipment.com. Are you facing the challenges of CO2 shortages in your construction projects? Secure your CO2 supply today with Tomco Systems, the pioneers in CO2 equipment solutions. With over 45 years of experience, Tomco transforms challenges into solutions, offering a comprehensive range of CO2 products for water treatment, storage, and transportation. Tomco Systems' patented CO2-based water treatment and wastewater treatment solutions have gained global recognition for their efficient and precise pH control systems. Whether you need pH reduction for municipal process treatment or industrial wastewater, their line of carbonic acid storage and feed products will provide you with 95% or greater efficiency in reaching your target pH. Don't let shortages slow you down. Visit tomcosystems.com to learn more.
And so, just to clarify, so you've got lime to pozzolan, and then you've got, so one of them's lower, one of them's higher.
That's right.
And what is the pozzolan?
So a pozzolan is essentially any reactive material that can be put into a cement matrix that goes on to generate calcium silicate hydrates down the road, or calcium alumina silicate hydrates that further densify and increase the performance of the concrete mix.
So that density is going to be good for longer lasting concrete,
exactly,
I would imagine.
Exactly. The core chemistry of Graybond is that, the pozzolan and the way it interacts with the cement matrix is through the generation of calcium hydroxide in the cementitious hydration reaction. So in cement hydrates, you start with this calcium silicate or calcium aluminate or calcium aluminate silicate. Alumina silicate, and those react with water to form their same coefficient in hydrate. So you end up with a calcium silicate hydrate. But in the process of that reaction, you also generate calcium hydroxide, which is a Graymont product, right? We manufacture pure calcium hydroxide. Well, that calcium hydroxide doesn't do anything to your cement matrix to improve strength or durability. But when you add a pozzolan in, right, the pozzolan is reactive and contains no calcium, but it goes on to react with that excess calcium hydroxide generated in this cementitious reaction to, like I said, further densify the material.
Okay, so that's some good background on the it's B2 and B4. So you were testing these both at Indian Creek then as well.
Exactly.
Okay.
So, but that's really a core. That is the thesis of the Graybond product, right? By including some reactive calcium with a pozzolan in a mix, you can actually extend the total amount of cement that you replace in the overall cement matrix. Now, the challenge is, what is the proper ratio of calcium to pozzolan? So, and each pozzolan can react differently. And through our research, we found more reactive pozzolans and less reactive pozzolans that perform better than others, right? And in this trial, we aim to see, well, which one is going to perform better over time, the higher pozzolan or the lower pozzolan mix. And it's challenging because our higher lime blend performed better in strength, but we don't know how it'll perform in durability. And our higher pozzolan blend performed maybe not as good in strength in the preliminary testing, but we don't know its durability characteristics either.
So you're doing all this in like labs and that, testing all these different combinations basically, like before you do obviously the real world trial.
That's right. So we've done a whole bunch of that testing, and we continue today to do loads and loads of Graybond testing at our central lab in Salt Lake City. Okay,
and then so you're there for the pour. It's actually good weather for that pour, and let's obviously is this over one day that they're doing this?
Yeah, so it was one day. So I think I got there around 7 a.m, and I explained the weather right. It was like 65, 70 degrees, partly cloudy. The temperature was going down a little bit, and we did our first pour. Everything went really well. I asked the finishers, how everything was going. I talked to the engineers on site. The slump was really good.
Slump is, I saw that mentioned a couple times, like when I was looking at the notes. What is that referring to?
Slump essentially refers to the workability of a concrete mix. So,
okay.
In a good performing cement or a good performing concrete will have a minimal amount of water in it, and that would generate the most durable and the strongest product.
Okay.
But if you don't have enough water, then you don't have a product that the finishers can put into place, and you won't get good particle packing, right? So if it's not flowing, then you can't actually have the aggregates touching each other. And minimizing that void space that could be detrimental to the durability and the strength performance of the concrete.
Right.
So you're always looking for this sort of happy medium. And while, in the lab, we can say we're looking for a water to cement or a water to binder ratio of 0.3, 0.35 or something like that to minimize, have that perfect workability and water ratio. They can't exactly do that at a ready mix plant, right? They need to be able to add water to get it to the flow standard that they need it to be. And then when that concrete gets on site, an engineer will take it and they'll put it in it's called an Abrams cone, and you sort of have this stacked cone and you pull it up and then you measure from the top of the cone to how much that concrete mix or concrete cone now slumped, and that's your slump value. So
got it.
If it's too much, if it's over 7 inches, then you have too much water in your concrete. And if it's under 5 inches, or whatever the standard is that day, then you don't have enough water in your concrete essentially. So all that to say, we had the proper amount of water in our concrete. Our slump, our workability was good.
Yeah.
The finishers were happy because they could finish it well. And in this first blend, this B2 blend, they actually said, this concrete finishes on what they considered like a residential, I don't want to say high grade, but kind of high grade, something that finishes really nice, right? And makes a nice smooth finish, easy to work with, compared to the other type 1L limestone cements that were scattered throughout the other or previously poured on the other sections in this paving project, which they said finished more as a commercial grade concrete, which isn't necessarily bad. It just means, right, it didn't have that smooth texturable finish.
Okay.
For over 50 years, Pedro has established itself as a global leader in water, energy, and technology solutions for various market sectors, including residential, commercial, industrial, agricultural, and even swimming pools. Pedro offers a wide range of pumps, including surface pumps, pressure boosting pumps, submersible pumps, and more, catering to both clean and dirty water applications. The company's automated designs feature world-class engineering, innovative mechanics, and advanced automation, all aimed at enhancing performance, all the while empowering trade professionals to optimize their efficiency and reduce costs. Pedro is at the forefront of pioneering water solutions for a dynamic world. Visit pedrolousa.com to learn more. Pumping systems. They're the heartbeat of manufacturing, but they can be real headaches, can't they? Vibration, pulsation, back pressure, it's a wonder anything gets done efficiently or safely. That's where Blaco comes in. Their pulsation dampeners, back pressure valves, and other solutions are designed to tame the chaos, improve efficiency, and add reliability and safety to your pumping system. Imagine less downtime, lower maintenance costs, and a whole lot less stress. That's the Blaco difference. Blaco Industries, smooth flow, smooth operation, made in the USA. Visit Blaco.com to learn more.
Okay, so then you're basically doing a B2 section and then a B4 section at this. The going into So you've measured the results, you've got good slump. What are other results that you're looking for from that, like initially?
So we're also looking for air entrainment value, which I can't remember exactly the value that they're looking for. But air entrainment is important in heavy freeze thaw environments like that at our Indian Creek plant in Montana.
Yeah.
Where you want these sort of microscopic air bubbles within your concrete matrix so that as water penetrates into your concrete, water as it freezes, it expands.
Mm-hmm.
You need to have space for that water to spread should you encounter freezing. Right. And then thawing as it melts, you need that water to go somewhere as well. So you're basically controlling the sort of pore pressure that excess water can have in your concrete matrix through inclement weathers.
So there is a workability. You have there's this other things like set time, comprehensive strength, durability. Those are all being measured as well during this.
Yeah, so I mean, the durability is going to have to come over time. We're taking core samples and measuring the strength of that as we go. We took our first core samples, I think, back in April of this year, maybe, and tested them for unconfined compressive strength. And we got a result that was a little bit better than a fly ash grade of concrete.
Okay.
So we were really proud of that. We're measuring compressive strength, which is part of that comprehensive package, I guess. And that compressive strength came in really quite well. It exceeded all of the ASTM standards, especially with that B4 blend. We were getting really quite good strength results early on. The nature of Graybond, because it's a pozzolanic cement, it's always going to have a little bit slower of strength generation compared to an ordinary Portland cement or a vanilla GUL cement.
Okay.
And that's just the nature of the pozzolanic reactions. But we were happy to be meeting those 7-day targets and those 28-day targets. And, we even saw strength development through 56 days. So really good long-term strength performance.
Yeah, because that's the one thing that people, if they've watched some of the other episodes with Graymont, the concrete will have a certain amount of time where it's gaining strength, right, before it stops. Is that correct?
That's right.
And you're obviously trying to, with this, still have that long strength profile.
Yeah, that's right. I refer to it a lot of times as like thermodynamic stability, I guess, right? In the instance of cement, you generate a lot of strength very rapidly, but that doesn't always mean that you're going to end up with strength that lasts. And that's because you're sacrificing maybe a lot of that long-term strength for that early rise, which is great, right? Like that type of cement is what makes us able to build, massive buildings like the Empire State Building and massive high rises that are the fabric of the world we live in today. But working with a product like Graybond that sets more slowly, we're hoping to increase the longevity, which is also good for the carbon footprint overall of the concrete mix, right? If you don't have to replace it as often, then you're not going to be spending as much CO2 as you need to use more and more cement.
Even all the transport, all that part of it as well. You've got a huge elimination of that too if you extend that life.
Exactly.
So with both those pours now, how are you seeing, like, what do you think this means for the construction professionals? Like, how do you think Graybond's going to end up benefiting them long term?
Right. So, and it's a really good point, or a really good question to ask, because as I mentioned already, Graybond is not theoretical anymore. We have our first ever plant now operational in Wisconsin. And there is a massive push in North America and globally to decarbonize our concrete and decarbonize our cement. I know there's billions of dollars that have been awarded to departments of transportation across the U.S. now.
Okay.
In decarbonizing, their Department of Transportation project.
Yeah.
And one of those in particular is like the Colorado Department of Transportation. I know they have a mandate now, a bill that was passed by the Colorado legislature, where every expansion of a freeway has to be counterparted with a low carbon project, whether that be in some sort of EV electric vehicle stimulus, or decarbonized project. And I think that's one of those really good places for Graybond to fit in, because we're decarbonizing the the expansion project, the freeway project, the paving project at the source by helping to decarbonize the concrete. It's going to mean huge things for companies like the Googles, the Metas, the Amazons, the Microsofts of the world as AI is expanding and we keep pushing the limits of computing power. They're building massive server warehouses across North America and across the globe, really, to power these new technologies. And, the tech is amazing, and it's obviously changing the world and will continue to change the world. But those warehouses and server warehouses are going to require massive amounts of concrete to build the walls.
I wonder how thick those slabs are that they put down for those.
Yeah, seriously.
Monsters. But yeah, that's a really good point because they're ever expanding. You hear about it. It seems like every month. It's like they're looking at new ways to increase their computing power everywhere.
Right. And those companies, they're answering to their shareholders now. They've made promises to their shareholders of carbon reductions, and we think a product like Graybond is going to be huge for any business that wants to lower their carbon footprint.
I guess one thing too is your goal with the Graybond too is, like you said, if you're expanding a major highway, they're going to be able to use that for all that paving too, eventually, right?
That's right.
Okay, excellent. Have you been hearing back from, does Graybond have customers yet, actually?
Yes. So we have, we're still in our launch phase. We just made our plant.
Yeah.
It came online in
You're
April.
a startup within a massive company.
That's right. So we now have a growing customer base. We have our initial customers. We have our first tons of Graybond going out the door.
Okay.
So that's really exciting.
I guess a follow-up to that is, so you've got those customers coming in. I saw about this when I was doing the prep about fly ash. I was like, I could Google this, or I can just ask the expert. What is fly ash?
Yeah, so fly ash is a byproduct of coal-fired power plants, where your coal is mostly a carbon source that generates the heat that generates electricity. But in that coal, you have pieces like calcium and magnesium and silica and alumina. And essentially what comes out in that ashy material is a clinker of cement, or it's not exactly cement, but it does have a clinker factor.
A clinker factor.
Yeah, I call it clinker factor sometimes. I think multiple people in the industry do.
It's probably a term everybody knows in concrete.
At least for today, we'll refer to it as clinker factor. So you end up with these sort of calcium silicates that aren't as precise as a cement clinker, but they are used as supplementary cementitious materials in concrete blends. And they do things like improve workability and, the same thing that a Graybond would do. They improve the densification and the durability of your concrete over time. But fly ash, we've talked for however long we've talked now about decarbonizing, and a big part of that is going to be getting rid of coal-fired power plants.
Yeah, that's another huge. Just saying that, you're like, okay, well, there's a huge avenue.
Right. So one of the byproducts of the coal-fired power plants is something that was being used to decarbonize concrete, and now that's going to go away. Another part of this is ground granulated blast furnace slag, which comes from the steel manufacturing industry.
Okay, it's
similar but not quite the same. Supplementary cementitious material that comes as a byproduct of a blast furnace. So they end up, and it's the same thing like I just explained. It has a strong, a high clinker factor.
It's actually interesting that you're with Graymont looking to decarbonize cement. We've had other companies on talking about decarbonizing steel making. So it's all kind of moving towards that direction.
Yeah, and steel is... as they decarbonize, they're switching from what they refer to as these like integrated mill circuits into electric arc furnaces, or mini mills as they're sometimes called. And those are not just only for decarbonizing steel. The mini mills are very good. They're much more cost effective for a steel manufacturer, and they're more portable and modular. They can scale them and move them around as they need fit. And Graymont, as our main product line is calcium oxide, calcium hydroxide, calcium carbonate, right?
Yeah.
The steel mills are actually, those are serious customers for us, and we have a unique pulse on how this is changing, right? So I think we have a pretty good idea of how these industries are going to change, and we're putting a lot of cards behind this Graybond product, and we think it's going to be very important in the coming years, right?
Yeah, and you get into, well, all the heavy industry we cover. You've got the big miners, like you said, the steel mills. They all need these big concrete pads for their equipment to be running on. So
yeah, you really start to see how it's just also circular, and everyone's relying on each other. And as things decarbonize, there needs to be new products put in place.
Mm-hmm. And like you said, it can't be. Actually, I don't know if you said it. I was just thinking about it. Like, you can't have it be all the startups. You kind of need people in their lanes with expertise in those sectors to drive a lot of that. For one, they'll have the capital, and two, they'll have the expertise with how it was. Like with the testing that you're doing, you can see what needs to make a better product in a sense and last longer. At least from like listening to with this conversation, it makes so much sense, especially when I link back to the steel and what they're doing in mining as well. Yeah,
that's completely correct. You know, cement has been used for hundreds of years now, at least the cement that we know of, right? The ordinary Portland cements. And it's very difficult to change an industry that has been working for so long, and everyone knows that it works, right? Why would anyone want to change? And we covered that question earlier, right? There's plenty of reasons to change, but we're going to have to. There's many steps in making these changes, right? All of the standards, everything is set up for the cement industry, and it's. I don't want to say it's pushing out, but it's created the challenges for the startups and for these alternative materials like Graybond to work in. One of the areas that makes us unique and I think leads to our success is just the fact we're already scaled, right? We're ready to produce and supply this material, whereas the startups don't really have that.
Because you'll have plants.
Exactly.
All throughout North America and worldwide probably that you can.
Yeah, we're a global company. We have plants all across North America. And on top of that, we're logistically integrated. We have an amazing logistics team. We know how product is delivered. The major customers that are buying cement, they use the same railways that we use, right?
What are you hearing from the customers on, like, is there main ones that they're coming to you with?
Yeah, a big one is always, of course, well, how much carbon does it reduce? Depending on the blend, we can reduce the carbon footprint by up to 70% compared to ordinary Portland cement.
70%?
Up to
70%. Okay.
So, Graybond is a customizable formula, which is another question we get because we tell that to our customers, which isn't necessarily always like a big deal in ready mix, because in ready mix, it's a very controlled and engineered product. But I actually specialize more in like the mining side in a industry called mine backfill. And we've had lots and lots of success in soil stabilization as well.
Is that for like just mining? You say mining. I'm like, I have to ask. So the backfill stabilization, is that for like if you're doing a tailings pond or dam? Is that what they're using that? Or is it in other applications?
So I guess flipping the above ground tailings pond on its head, right? So if you have an underground gold miner or silver miner, whoever, they'll be going underground and blasting and mucking. And then you're left with all this empty space after you've processed your ore. And what mine backfilling does is it essentially takes those tailings and mixes it with a binder and gets it into a slurry state, so you can pump it back underground and refill your stopes and generate that mechanical strength that the cement binder will generate. And in doing that, you solidify above, and I guess they call it undercut a lot, where you'll go underneath, right, and then you'll blast and muck out again. So it does a few things, and the two most important is that it builds a very robust tailings repository, so you don't have to have this ecological hazard that's sitting above ground.
That is amazing, actually. Yeah. That they're just kind of, it's just, you get out what you need, and then you put it back in.
Exactly. And then it creates that mechanical strength so that you can maximize your recovery, right? If you leave all these columns underground, you can go back and excavate the columns, which could contain sometimes your highest grade of ore body. So that's mine backfill. And, there's a lot of interesting and unique challenges in mine backfill. And I think one of the interesting parts is actually that they use blast furnace slag or slag cements as their primary binder. These are the binders that work best for the mine backfillers. We have a product that can be used to completely replace the slag in the slag cement. and fill that void that is going to be left as the exodus of slag occurs, and as we're switching from the those integrated mills into mini mills. So
on that customization that they can do, so obviously there's the you just said, is it ready mix? I think you said, where it's not as that's more of a
and ready mix, you want to give them a product that they can use to deliver to the end customer.
Yes.
In things like soil stabilization, or in mine backfill, right? There's different soil types and different tailings types and different operational targets that they need to hit or achieve in order to have a successful material and a successful performing structural material. So in those instances, we're actually able to go in and work with the unique type of soil or the unique type of tailings and create a Graybond, that has the right proportion of pozzolan to lime, etc.
So you can take those soil samples and completely that is customizable based on like how much you use.
Exactly. We'll take their materials into our lab and do our research and come up, present to them the best performing Graybond for their use case.
So yeah, we've covered, there's carbon footprint, there's customization. And then is there any other things that they're coming to you with? Especially, there is a lot of questions around. I remember when we started just doing this, people were like, what do you mean you do a video podcast or show? So I'm sure you get piles of questions.
Yeah. I mean, the core competencies of the product we get asked about a lot as well, right? Like, what kind of pozzolan do you use? And well, I guess the answer to that question is we can use any pozzolan. We remain open to using any type of pozzolan because we think that we can find the best type of pozzolan, the most effective type of pozzolan for the final application. And then in line with that pozzolan question is, well, how much lime do you put? How much calcium, reactive calcium, do you put into your Graybond product? And it's sort of in line with that pozzolan, right? Because we know pozzolan and because we research so much pozzolan, we know and we continue to learn more and more about how much reactive calcium each unique pozzolan needs to create the most effective Graybond product. And I think that's really most of those sorts of questions. Those are some of the most frequent questions that we get asked, right?
Okay.
Like how much carbon reduction, what pozzolan, what type of lime.
I like kind of going into this at the end. So it's a good time to. So your background, we didn't really get into that. Obviously, you have extensive knowledge on Graybond, but it's good, like, kind of in closing. What has been your role throughout, like, this whole process? Have you been with Graybond, like, in that segment for quite a while now?
So I've been with Graymont almost 4 years now, and I started in the lab. So and I've only been, I guess, out of the lab for the last year or so. But I live in Salt Lake next to our central lab. I'm in the lab at least every week if I'm not traveling a ton. So I've been with the Graybond project from the very early days, testing it out in the lab. And now I'm sort of, taking my learnings and all this work I've done in the lab and letting the world know. I'm now in charge of taking all the success that we've had in the lab and deploying it to the market and getting the Graybond into the hands of the people who need it.
So are you a scientist by trade or engineer or both?
I'm scientist by trade, or at least by education. I'm a chemistry major. That's what I graduated with back in 2018.
Way above my brain levels.
Well, that's okay. Nowadays, I guess I consider it more like materials science, which is sort of right that intersection between the chemistry and the engineering worlds. Okay. So trying to take these, chemical principles and make them usable. Cement is like one of the huger, like, major parts of material science, next to like computer chips, right? Like silica.
That makes sense. Yeah. That's really interesting. And I guess in closing too, is there anything maybe that we didn't touch on that is important for the audience to listen? Or I mean, we're going to put links to everything for, obviously, Graybond for them to find out more information, even to contact you directly and your team. But is there anything else maybe that's kind of important to just touch on?
We continue to have publications in both previous expos and conferences and future expos and conferences. You can go to graybond.com to see all of our publications. I know I touched a few times on our first production facility in Superior, and I should also mention that we have 2 more production facilities that we aim to have come online in the second half of this year and first half of next year across North America.
And just for the construction show audience, we will be doing an episode at your Superior location coming up soon, so stay tuned for that.
Great. I think that's really it. Our central lab is in Salt Lake City, Utah. Oh, I was going to... a question that I didn't ask that I wanted to. So you did the paving test with the, I'm gonna make sure I get this right, with the Graybond B2 and the Graybond B4. Now are you doing more tests, or are you now getting it out into the market? We are getting it into the market in mining and in soil stabilization. That's where we had our first ever successes, right? In ready mix and concrete applications, I think there's a few more barriers, a few more roadblocks. And, like we were talking about earlier, we're shaking up an industry, and we need to make sure that we're dotting all the I's and crossing all the T's. There's always going to be a lot of questions. So as this durability, this first ever pilot trial progresses and we get to measure the durability, we have other pilot trials coming online.
Okay, you're going to do more. Okay, kind of stack up the data.
Yep, of course.
I just wanted to get that one in there because I was like, oh yeah, that's just the first. You're probably doing more and more. So that's a great, it's been great learning more in detail about that. And I'm just going to, again, everybody check the description. We'll have all that. And thank you for watching the construction show. Please subscribe on YouTube, follow on LinkedIn, follow Graymont on LinkedIn, subscribe on YouTube as well. And we will have a whole bunch more content on the construction show coming soon. Thank you for watching, and we will see you next time.